Hello! In this tutorial, you will be learning how to use a mask in Pygame. And you can use that in a couple of different ways. Most importantly, using a mask enables you to do pixel-perfect collisions. But you can also use a mask to fill a surface or give it an outline. And if you push it a bit further, you can also color in the overlapping areas between two surfaces. And all of these projects are going to be what we will cover in this video, which should be a reasonably extensive introduction to using a mask in Pygame. So let's get started and talk about what a mask is in the first place. If you have used Pygame even for a little bit, you will know two objects: surfaces and rectangles, or rects in short. A surface holds an image and is basically a rectangle with pixels, and each pixel represents a color and a transparency. And a surface does not contain any positioning information or any means to check collisions with another surface. All you can really do is to change the pixels to make it look different and to get some basic information about it. Now, if you do need positions and collisions, you would use a rect. This object is basically a rectangle with points that you can move and measure. And you can also check if a rectangle collides with another rectangle or overlaps with a point. However, you always work with rectangles, so if you want to check for collisions between irregular shapes, you would struggle quite a bit. But for that, we can use a mask. And a mask is somewhat similar to a surface, in the sense that it contains information for each pixel and uses that to draw a shape. However, each pixel only stores either a 0 or a 1, instead of a color information. 0 means that the space for this pixel is empty, and a 1 means that the pixel is occupied. Now, I assume by itself this is a bit confusing, so let's do this a bit more practical. Usually, a mask is generated from a surface, and in that process, Pygame goes through every single pixel of that surface, and if a pixel is transparent, then it will create a 0 for this particular pixel. However, if any of these pixels has a color, it will be a 1 in the mask. And that way, we can tell which parts of the image are occupied and which ones aren't. And that information can then be used in a couple of different ways. The most common one is for collisions, because you can check if one mask overlaps with another mask on a pixel by pixel basis. What you can also do is to take a mask and convert it back to a surface, and then color each of the pixels. That way, you can turn an entire surface into a single color or color specific parts of a surface, like the surrounding area or any overlapping surface. And that is basically all you need for the basic theory. So let's get started with the easiest kind of a mask, a collision mask inside of a sprite. And alright, here we are in the code and I've already set up a couple of things. Now, if none of this makes any sense to you, you probably want to check out my introduction to Pygame. It explains all of this in quite a bit of detail. But ultimately, what we're seeing in here isn't all that difficult. And let's run it first, and then I can talk about it. So, if I run this code, you can see a white background, a big alpha, and a red rectangle. And the red rectangle I can move around with my mouse. But besides that, really nothing is happening. So let's close it, and let's talk about the code. Now, the really easy parts here are this part, and let's say this part down here. Because all of these are the super basic setup for Pygame. So if you just wanted to create a basic window, this is what you would need. Now I guess on top of that, in this line here, I am filling the background with a white color. So we have a white background color. Now, the actually more interesting parts are these two classes up here. And I'll talk about them in just a second. But first of all, be aware down here, each of these classes is initiated inside of a group single. So we have one group single for the player and one group single for the obstacle. And it is important to keep these two in separate groups. You're going to see in a second why. But, well, each group is either called player and obstacle. And then in our game loop, we are drawing both of them, and the player also gets updated. Why only the player gets updated, you will see in a second. But these are the two classes we are going to need. So let's have a look at them. The first class, let's look at the obstacle. That's the easier one. And in here, you can see, well, that not much is happening. We are inheriting from the sprite class, so we're getting a sprite. And then in there, we are creating an image and a rectangle. So the basics you need for a sprite. And I guess the one thing in here is that for this class, we are importing an image. And this image is in the same folder. But that still isn't anything particularly complicated. So with that, we can minimize this class and not worry about it anymore. So let's have a look at the player. And this one is slightly more complicated, but not that much. I guess, first of all, we are importing a sprite. And for the image, we are creating a plain surface and we are filling it with a red color. And by default, we are placing the center of this image at a position 300 and 300. So all of this is going to be very similar compared to the obstacle, except now we don't import an image, we are creating one in Pygame itself. Now the slightly more interesting part for this class is this bit here. And what this one does is it checks if there's any kind of mouse position. And this is going to exist as soon as we are moving our mouse. And once I have that, I want to set the center of the rectangle to wherever the mouse is going to be. And that way, all of the stuff up here is always going to follow the mouse. And this is also why we have to update the player group, because only with that we are calling this method here. So let me minimize it, and now we can start to work on the collisions. And let's do this in the game loop, and let me add a comment. Let's call this collision. Now, usually what you would do in Pygame to get a collision with sprites is pygame.sprite.sprite collide. And then here you have to pass in 3 different arguments. You need a sprite, you need a group, and you need what is called doKill. And let's go through all of them one by one. Now, the sprite has to be a single sprite. And in my case, I want to look at my player. So essentially this player here that I'm passing in there. However, this player right now is not a sprite. It's a group that contains a sprite. So this is a group. As a consequence, we couldn't use player straight away here. We would get an error. But we can fix that quite easily. All we need is player.sprite. And that way, we're going to get the one sprite inside of this class. Now, next up, we need a group. And this one is quite a bit easier because we already have our obstacle group, and this actually is a group. So this we can just pass in here. So literally, all I want to do is to get my obstacle. And with that, let's get rid of these lines. Now I need a doKill argument. And all this really means is if this sprite collides with a sprite inside of this group, do we want to delete the sprite inside of this group? So this can either be true or it can be false. In my case, I do want this to be false because I don't want to delete the alpha inside of this group. And alright, with that, we have a sprite collision method. Now, what this method is going to return is a list with all of the sprites that are overlapping or, well, colliding. So what we could do, for example, is use this in an if statement. Let's say I want to print the word collision. And now if I run this, and I move my red rectangle somewhere to the alpha, we get collision in the bottom left. However, if you look very closely, the red rectangle didn't actually touch the alpha itself, at least not the alpha as we can see it. And the problem here is that sprite collide by default uses the rectangle of the class. So we are basically checking the rectangle around the alpha, which usually works, but sometimes, especially in this case, really does not work well. And there's this huge amount of white area around the alpha that still checks collision. So this is not going to work. Now, fortunately, we can fix that very easily. There are 2 things we need essentially. Number 1, for each of the classes, we have to set a mask. So the player and the obstacle are going to need a mask. And then besides that, we have to add 1 extra argument into sprite collide to check for a mask and not for a rectangle. So let's start with the first one, and let's give each of these classes a mask. And this is actually incredibly easy. All you need is to add another attribute called self.mask. And this has to be called a mask. And now we have to generate a mask from this surface here, or well, the image of the sprite class. And this is also very easily done. All we need is pygame.mask.from_surface. And this method is going to need one argument, and that is the surface we want to convert into a mask, which in my case is self.image. So all I'm really doing is I'm getting this image and I'm passing it in here. And then we are good to go actually. And now we have to do the very same thing for the obstacle. So literally all I have to do is copy all of this. And now this obstacle also has a mask. So now I can minimize these two classes again. And now we come to the second step. That sprite collide needs another argument, argument number 4. And this is basically to tell it that we are looking for the mask and not for the rectangle. And for this one, we actually have a couple of options. If you check the documentation, you can find all of them. So we have collide rect ratio, collide circle ratio, and collide mask. Collide rect is the default one, basically. And we want to check for collide mask, obviously. So what we have to pass in here is pygame.sprite.collide_mask. And with that, we have a mask collision. That's literally all we needed. So now let's run this again. And now look very closely. My red rectangle is inside of the rectangle of the alpha, but we cannot see collision in the bottom left. However, once I touch the black part, so let me be very careful. Now we can see it. That's really all there is to the most basic kind of mask collision. Now let me actually make this a bit more visual so it's better to see. So if there's a collision, I want to get my player.sprite.image.fill and fill it with a green color if there is a collision. And if that is not the case, so else, I want to copy all of this and fill it with red. This way, all of this should be easier to see. So now let's run this, and I'm getting an error. This double colon shouldn't be there. So now let's try this again, and there we go. So now I can move the red rectangle, and if we're touching the alpha, it turns green. But if we're not, even though we are in the rectangle of the alpha, it's red. And this is working even inside of the alpha. So in here, every time I touch the alpha, we get a green rectangle. And this is working remarkably well. So all good with this one. This is actually really workable. Cool. So with that, we have the most basic use of a mask in Pygame. And I guess the one thing you really have to be careful here, let me open both of these classes, is that if either of these classes were animated, you would have to create a new mask after every time you are running the animation. Basically think of anytime you're changing this surface here, you want to create a new mask. But that's about the only mechanical thing you really have to worry about. Although I guess the other thing you also want to worry about is performance, because mask collisions are quite a bit more performance heavy than normal collisions, or well, rectangle collisions. Because remember, checking every single pixel inside of both sprites is quite a bit more difficult than just checking rectangles. Now there's one thing you can actually do to make all of this quite a bit more performant. And that is that you first check a rectangle collision, and only if you have a rectangle collision, then you check a mask collision. And this is really easily done. All I have to do is copy all of this and create a new if statement with the normal sprite collision, so no mask whatsoever. And only if we have this kind of collision, then I want to check a mask collision. So this way, you're only checking a mask collision if both of these sprites are very close to each other, which, especially if you have a lot of collisions, is going to make your game run a lot faster. But if I run this, we still get the same result, except now we are only checking a mask collision if the rectangle is roughly in this area here. But if we're outside of it, we're not checking it at all. So this is going to help our performance quite a bit. And all right, so this is then the first project in a mask. And this is probably how you want to use it in most games, because it's really easy and incredibly useful. But you can also use a mask much more flexibly. So for the next project, we are going to do the same thing, but we are going to do it with without a sprite class. And I guess let's jump straight into the project and let's have a look at this. And all right, here we have a new project, and if I run all of this, we can again see the alpha, and we have our red rectangle that we can move around with our mouse. So let's first talk about how to set this up, and then we can talk about the collisions. Now guys, at the top, we're importing the normal stuff, and then we are setting up the basic things for Pygame. Then we have one section where we are creating the player. So we have a player surface that we are filling with a red color, and then we have a player rectangle that by default is in this position. Although this position doesn't really matter because further down here, as soon as we have a mouse position, we are setting the center of this rectangle to wherever the mouse is going to be. And this is very similar to the class we have just seen. And once we have the rectangle and the surface, we are letting the player where the mouse is going to be. Now, besides that, we also have our obstacle down here. And this one is just going to be a surface, and we have a position. So there isn't even a rectangle. And all of this we are blitting in this line of code in our game loop. And I guess besides that, we're also filling the entire thing with a white background color. We have our event loop. And let me close all of this. And all the way at the bottom, we have the usual updating and our clock. So this again, it shouldn't be difficult if you have even the basic understanding of Pygame. If you don't, I would really recommend to check out my basic Pygame introduction. Now let's talk about collisions. And in here, if you wanted to do normal rectangle collisions, you would basically create a rectangle for this obstacle. But in this case, we are not going to do that, for the simple reason that we want to have masked collisions. So the first thing we have to do is to create a mask for each of our surfaces. And let's call it player_mask. And I also want to have an obstacle_mask. And this mask will be created in exactly the same way that you have seen in the sprite part. So this could actually be a good exercise. Have a look at the sprite part and see how we created the mask there. And now try to do the same thing by creating a mask from the player surface and from the obstacle surface as well. All right, let's do it together now. So to create a mask from a surface, we need pygame.mask.from_surface. And in here, we have one argument that in this case is going to be the player surface. And then we can copy all of this for the obstacle. And now this has to be the obstacle surface. And now if I run this, we should not be seeing any difference. And looks good. I guess the one thing to look for here is if we're getting an error message, which we don't. So that's a good sign. So now that we have our mask, we can actually, in our game loop, look at the collisions. And again, let me add a new section here. So collision. And outside of the sprite class, you essentially have two ways to check for a collision with a mask. One is called overlap, the other is called overlap area. And both of these methods work in basically the same way. The difference is in what they return. In overlap basically returns 1 point if there's any point of overlap. Overlap area returns how big the overlap is, so how many pixels are overlapping. But let's start with overlap by itself. And to trigger this, again, we need an if statement. And we need one of the masks. It doesn't really matter which one. In my case, I want to go with my player mask. And then here, we could either call overlap or overlap area. In my case, I just want overlap. And in here, we have to pass in two arguments. The first one is the other mask we want to check, and the second one is called an offset. And let's say for now, if that is the case, I want to print collision. So let's figure out the parameters in here. The mask is the easy part, because all we really need is this obstacle mask up here and pass it in here as an argument. Literally, all we have to do is pass in obstacle mask, and we are good to go. Now then, what is the offset? And this is a slightly confusing part at times. Basically what Pygame here wants is that we pass in an X and a Y position, so that the top left of this mask is in the same position as the top left of this mask. Why that is specifically necessary, I have absolutely no idea, but Pygame does want it. So let's add a couple more lines of code and let's fix this. And I guess let's name this properly. Let's call it offset X and Y. So we have offset X and we have offset Y. And essentially what we are looking for in here is, for example, for X, is how much of an X do we have to add to our player mask to put it in the same X position as our obstacle mask. And let me actually draw what we are going to need here. Let's say in yellow, we have our obstacle mask. That looks like this, and let me call it O. And then besides that, we have our player mask. And let's place it somewhere here. And let's call this one P. Basically, what Pygame wants to know is what is this distance here, and this is going to be the offset for X, and it wants to know what this distance here has to be, and this is going to be offset Y. And then if you combine these two offsets, you're getting to this position up here. And that way the player mask and the obstacle mask have the same top left position. And fortunately, both of these points are fairly easy to get. The first thing we need is the top left position of the obstacle. And this is stored up here in our obstacle pos. And this is a tuple with X and Y. So let me copy this thing. And in here, I want the first item, and then I want the second item. So this is going to be X and Y. And from that, I want to subtract my player rect dot left and my player rect dot top. And let's do a really quick example to illustrate how this is going to look. So here again, we have our obstacle. And let's just focus on the X part now. So this line here is position 100. And now let's place our player again somewhere down here. We have our player. And let's say the left of our player is at position, let's say 300. So to place the left side of our player to the left side of the obstacle, we would need this distance here. And remember, this number has to be negative because we want to move this player to this side. And to get this number, we would need 100 minus 300, which would be the same as negative 200. And this is exactly what we would get from this line here. And then the same would be applying to the Y position as well. And I guess with that, we literally have all we need. Let's actually try this. And now if I just move close to the alpha, we get nothing. But if there's a collision, we can see collision. So this is working really well. So this is then what you are going to need for a mask collision without a sprite class. And I guess what we can also do is let's actually print what this thing is returning, because that's kind of interesting. So now let's run this and let's see what we get. So now if I touch the alpha in the bottom right of my rectangle, and there we go, we get 49 and 49. So this point here, although it does change the further we go down. And basically what this means that our player mask is a mask that has 50 points on the X and on the Y dimension. Exactly what we specified in the mask earlier. So let me actually close this and go to the surface. So in here, we are creating a surface that is 50 by 50 pixels. And then when we are using this surface to create the mask down here, we are creating a mask with 50 by 50 pixels. So our first pixel is 0 and 0, and our bottom right pixel is 49 and 49. And essentially, what this method here returns is the first pixel on the mask that has a collision. So right now, if I'm hitting the alpha with just the bottom right like this, we get 49 and 49. So the bottom right pixel of this mask. However, if I go to the other side, and let me scroll down all the way here. Now, if I hit this alpha with the top left, we should expect 0 and 0, because that's the first pixel in the mask. And if I do that, we indeed get 0 and 0. So this is exactly what we get here. So if you have some incredibly specific need to check for one specific pixel on your surface, this is how you would do it. But probably not particularly useful all the time. But with that, we have a basic collision with a mask without a sprite. Now there's another thing that we can do. And let me comment all of this out, but I am going to keep the offset for X and Y because we are going to need it. Right now, our overlap triggers as soon as we have a single point. But sometimes you don't really want that. So if you want a more forgiving collision mechanic, where collision only triggers if you have 5 or maybe 10 pixels of overlap. But then you wouldn't use overlap, you would use overlap area. And let's work with that. So again, I want my player mask.overlap, except now I want overlap area. But besides that, I will need the same arguments. So those two, let me pass it in here. And let's say again, just for start, let's print collision. If I were to run this, we would get pretty much the same result. So as soon as there's any kind of collision, we get collision in the bottom left. So this is still working. But now what is interesting about this method here? Let me copy all of it and let's see what it returns. So now let me run all of this again. And now if I touch the alpha, we can see we get 1, 10, and then again 6. And this is telling us how many pixels have been overlapping between our player mask and our alpha mask, or well, our obstacle mask, whatever I called it. And if I go all the way over this, we get 2500. And this is the number you get from the dimension of our player mask, because this one is 50 times 50 pixels. And if you multiply those two numbers, you get 2500. And all right, so now really what you can do is check if this number, let's say, is greater or equal to, let's say, maybe 10. So now if I run this, I can get a tiny offset, but now as soon as I get something greater than 16, we are triggering the collision again. But again, if there's only a tiny overlap, we do not trigger a collision. And of course, if you set this number to something greater than the pixels in the mask, let's say in this case 2501, we will never see this if statement here triggered. So now we don't get anything because there aren't that many pixels in the mask. But you could do something a bit more reasonable, let's say 100. And now I can move a bit over the mask and it's a bit more forgiving. So if that's your goal, that's how you would do it. So with that, we have the second way to approach a mask. Now there is a third kind of overlap, and that is called overlap mask. And this one is going to return a mask with the overlapping pixels between our player mask and our obstacle mask. And this is what you would be using to color in an overlapping area, for example. We're going to see that later in this video actually, but for now, don't worry about it. And instead, let's use a mask to color in a surface or to give it an outline, which is something you can do fairly easily with a mask. Essentially what we are going to do. We are going to take the surface we already have. Then from this surface, we are going to create a mask. And then this mask we are going to convert back into a surface. And this is essentially going to give us a black and white version of the surface we just created. And then we are going to go through every single pixel of that new surface and change each pixel to a certain color. Now, you might be asking, why can't we go through the original surface and change the pixels there individually? And the answer is actually quite simple. In the original surface, we probably have lots of different colors. And this is making it quite difficult to separate the visible from the invisible pixels. And the mask is going to fix that problem entirely. You're going to see later on in this video what this is going to mean in practice. But specifically in this part, we are going to either fill a surface or we're going to give a surface an outline, both of which can be done fairly easily with a mask. So let's jump straight into the project and let's have a look at this. So here again, we have an incredibly simple setup. Let me run all of this and we can see our alpha and nothing else. We don't even have the moving rectangle anymore because we don't need it. So literally all we're doing right now is that we are importing an image and setting a position here. And then down here, we are blitting all of this. And I guess we have a white background, but that's just about it. And the first thing we need is to create a mask. And this is happening in the usual way. So obstacle mask as a new variable. And this one should be pygame.mask.from_surface. And in here, I again want my obstacle surface. And now we have a mask. By itself, doesn't really do much, but well, we can use it. And essentially, let me add a comment here. What I want to do now is to turn the mask back into a surface. And I guess let's be a bit more consistent here. Let's give this one a comment as well, creating the obstacle. Essentially, what I want to do in here, I want to turn the obstacle mask back into a surface. And let's call this new obstacle surface. And to generate this one, we first need our obstacle mask. So the mask we have just created. And now this mask has a method that is called to_surface. And when we call it, we don't need any arguments in here. And now we have an entirely new surface. So what we can do now is in our game loop, I can copy this entire line with the obstacle surface. And now I can blit this new surface. And let's just see what happens. Now we can see something slightly weird. So we can see that we can still see the alpha. So all of this part here. But now it's white. And all of the other parts that used to be invisible are now black. So all of this part with the pink color now. And essentially what is happening, if we're turning a mask back into a surface, is that any pixels with a 1, so all of the white bits here, are becoming a white part in the new surface. And all the pixels with a 0 are becoming black in the new surface. So essentially what we are doing is we are turning all the visible pixels in our original surface into a white color and all the invisible pixels into a black color. We are basically creating a silhouette from our original surface. So now what we have to figure out is how to color in this thing. And the first thing that we have to do is to get rid of the black color. And this can be done quite easily. All we need is the new obstacle surface and then the method set_color key. And this needs an RGB tuple. And the RGB tuple is going to specify which color in this surface should disappear. And in my case, that is pure black. So 0, 0, and 0. And now let's see what we get. We get, well, a white color. I guess the white background color isn't particularly helpful here. Let me change this to a gray so we can see a bit better what's happening. And now, if I run all of this again, we can see a white alpha. And this is this new obstacle. So if I comment this out, we can see the original, let me move it to the side. So what we can see right now is the alpha of the original obstacle surface. And right now we basically turn this surface into a white color. So that's a pretty good start, I suppose. But now, how can we change this to any color that we want? Because you probably don't want this to be white all the time. You might be kind of tempted to go with something like new obstacle surface dot fill and then fill it with the color you want to go for. Let's say red in this case. If I do this, let's run this, it's not going to work because the pixels that we have hidden here are just that. They're hidden. They're still there. We just can't see them. So if we are filling the entire surface, these pixels are being filled in as well. So this does not help. So let me get rid of it because it really doesn't help us all that much. What we actually have to do is a tiny bit more complex. And let me explain it first. Essentially, what we have to do is we have to go for every single pixel of this new obstacle surface and check if the color of that pixel is white. And if that is the case, we are going to change that pixel to a specific color. And this we are going to do for every single pixel of the surface. And we can quite easily identify the visible pixels because they are all white. But in a normal surface with different colors, this would be significantly more difficult. And this is why we are using a mask in here. I guess let's have a look at turning every single pixel of this new surface into a specific color. So here I am back in the code, and let's add a new section, and let's call it filling in the surface with a color. And now we have to figure out a couple of things. The most important one is we have to figure out the size of our surface. And this is, well, quite easily done. We can get the size of our surface with new obstacle surf and get underscore size. And this is going to return a width and a height. And in our case, this is what we can capture. Let's call it surf underscore W and surf underscore H for surface width and surface height. And this information we can use to loop over every single point. So for X in range surface width, and then for Y in range surf H. And I guess just to illustrate what is happening here, let's print all of this. So print, let's turn it into an F string where we have X. Let's do it like this so it's actually working. Let's call it X and we get Y. And let's run this. And we basically get all the numbers from 0 and 0. Then we increase the Y all the way to 49. Oh no, this one is larger. So we get significantly more numbers. We go all the way to, it's quite a bit. There we go. So the alpha is 599 pixels high. And this is then going to be our first go through. And once we have that, we start with X being 1 and then we do the same thing. So we literally go through every single pixel of the alpha surface. So this is working quite well. Now this information I can use to check every single pixel of this alpha surface. And this happens with if my new obstacle surface and then get add. And all this method is doing is it looks at a certain pixel and then gives me the color. And this one needs an X and a Y coordinate. And this is going to look at a single pixel in our surface. And it's going to return a color argument. Now, in my case, I know the color argument it will return for all the visible pixels will be 255, 255, and 255, short for white color. So in my case, really all I need to do is pick one of those and check if those are different from 0. So I know that this pixel is white, and well, if it's any other color, I know it's supposed to be invisible. And once I have that information, I can get my new obstacle surface again, and then run set add, which kind of does the similar thing what getter does, except now we don't get a color, we are setting a color. And it needs, again, a tuple with the X and the Y argument. And besides that, it also needs a color argument. And in my case, I just want to go with orange. And now, if I run all of this, we get an orange alpha. So this is working quite well. And sadly, the logic here does get a tiny bit more complex. So I would recommend you to go over this a couple of times just to make sure you understand the logic. But really, all we're doing is that we are looking at every single pixel of this alpha. And if the pixel is white, we are turning it orange. And if it's any other color, so in this case black, we are just going to ignore it. And that way we can turn the new masked surface into any color that we want, while also ignoring the background black. And the reason why we couldn't use the original mask is essentially this bit here. Because for a surface generated from a mask, we know that this position is always going to be white. But in any other surface with various colors, we couldn't guarantee this. So we would always have the risk of one pixel accidentally being the wrong color and then it becomes invisible, which would look very strange. And the mask just ignores all of this. And this is why we are going to use it. Now with that, we can color in an entire surface, and this is going to work with pretty much any kind of surface. So this is quite good. So then let's talk about how to give a surface an outline. And there are two ways of doing this. One that is very easy, but also not exactly great. Then there's a slightly more complex one that, well, works much better. And I guess it's best to explain both of them straight in the code. That should make the most sense. All right, so here I am back in the code. And the first thing I want to do is to comment out all of this, because we are not going to need it for now. but later on we are going to need it, so don't delete it just yet. And then also in the game loop, I want to comment out the screen blit. So if you ignore the commented out parts, we are basically back to square one, where we only have our alpha surface. Although we still keep our obstacle mask. And now let's start with the first way to create an outline. And this happens straight in the game loop. And let me add a section here, and let's call it the simple way to create an outline from a mask. So basically what we can do in here is that every single mask, including our obstacle mask, have one specific method that is called outline. And well, this gives us the outline. It's, well, quite straightforward. And let's have a look what it gives us. So if we run out of this, we get a whole bunch of points. Right now, they don't really tell us all that much, but basically these points, if I draw them in, are all the points that are surrounding this alpha. So if I drew all of this, it will keep on going all the way. Let me speed this up a tiny bit. So these are all the surrounding points. Ignore this bit, it should look more like this. Now, importantly, what you have to be aware of, that it does not give us the point inside of the alpha. We only get the purple points outside of the surface. If there's a hole inside of the surface, it's not going to work. We are going to fix that later with a different method. But, well, now that we have that, really all we have to do, let me close this, all we have to do is go for every single one of these points and draw a specific pixel in this position. So what I can do is add for loop with for point in my outline. And in here, I want to use pygame.draw.circle. Let me spell this properly as well, that might help. And this needs our screen, so the surface we want to draw on. Then we need a color. In my case, it's going to be red. And then we need an X and a Y coordinate. We are going to create those in just a second. And then we need a size, let's say in my case, a 3. Or well, it's a radius it's looking for here. So now we have to create an X and a Y coordinate. So it's going to be X and it's going to be Y. I guess we haven't done an exercise in a while. So what I want you guys to do is to figure out the X and the Y coordinate. So try playing around with the outline points and see how far you get. It really shouldn't be all that difficult. So the first thing we need is the actual point. And this point right now is a tuple with X and Y. And we want the first one, so the X point. And then for Y, we want to do the very same thing, except now we want the first one. And I guess now let's actually try this. And this is almost working. So we do get an outline, but it misses the offset. And the reason for that is, remember, a mask does not have any positioning information. So the top left of a mask is basically always 0 and 0. And the same for a surface actually. So this obstacle surface is only in the middle of the screen because we have the obstacle position. And this one is 100 and 100. And this 100 and 100, we basically have to add to these points here. And this is also very easily done. All we need is the obstacle position with 0, and then I can copy all of this and set it to 1, so that both the mask outline and the surface have the same offset. So now let's run this again, and there we go. We have an outline. If you have very simple surfaces, this is already enough for most purposes actually. So if you need nothing fancy, this should work by itself. And you could even make this a bit more pronounced, let's say by giving it a 10, although it might be a bit too much. And I guess it still works. So now we can see it quite a bit more. Or if you set this to, let's say, a 2 or even a 1, now it is significantly more subtle. Although the obvious problem is, let me run it again actually, that if you want to color in the inner part, the outline would never be able to do that. So for this, we would need a different approach. But this one isn't that much more difficult, it's just a bit more writing intensive. And let me explain in theory what we are going to do. Essentially, we are going to use again our filled in surface. So the one we created in the first part of this section. And this new surface, we are going to blit multiple times behind our original surface. And we are going to blit it in every single direction. So left, right, up and down, and then top right, bottom left, and top left. And that way we are going to create an outline that is filling every single hole. So let's jump straight back into our code and let's have a look at this. So here I'm back in what we created earlier. And the first thing I want to do is let's comment out all of this so we can't see it anymore. So again, we are back to our alpha. And now what I want to do is to get back this part and this part. And I also want to blit all of this again. So now if I run the code, we get back our orange alpha. But now I don't want to have this alpha after the obstacle surface. I want to run this one before. And now what we get is, well, we can't see it anymore because it's behind the alpha. But now what we can do is to mess with the position. And let me actually demonstrate how this is going to look like. So I can set my obstacle position with 0 and my obstacle position with 1. So by itself, this is not going to make any difference. So if I run this, same result. But now what I could be doing is to change this position and give it an offset. Let's say 10. And what we can see now is now we have a color to the right of the alpha. All we have to do now is to apply this to every single of the 8 sides we could possibly move in. And well, let me put this into a section to keep it simple. So let's call it the complex way for a outline. And in here, since we are going to reuse this offset quite a bit, I'm going to put this into a separate variable. And let's call it offset, and let's put it at 10. So we first have the offset to the right, and I am incapable of spelling offset. And now, let me give a bit of space. We have to copy this thing 8 times. So let me do the first 4. This one is moving to the right. Let me actually add a comment afterwards so we can see what's going on. So this one is to the right, and this one is going to be to the left. So all we need for that is negative the offset. And now if I run this, we have a left and a right offset, or well, a kind of an outline. And now we can copy this again, and let's put this one at top. Now for this bit, we don't need an offset in the X at all. Instead, we need one for the Y. And now if I run this, we can see we now have a top part. Although if you pay close attention, you can see that we have this ugly bit and this ugly bit. And these can only be fixed if we're moving the background to the top right and to the top left. There's no fixing this if we just move up and left and right. This is why we're using the other directions. You can see it down here as well. It looks really ugly there. But we're going to fix those in a bit. Now, before that, we have to copy this thing one more time. And now the offset is going to be plus because this one is the bottom. And now if I run this, we have a kind of working background. And importantly here, now we have a filled inside. So this is covering every single hole inside of our surface. So now what we have to do is to actually fix these bits here and this bit here. And this is done by, well, continue going on. And let me actually add proper white space here. So now let's start this one with the top right. Now, first of all, since we're going up, this has to be negative. And since we're going to the right, like in this part here, we need this offset as well. So let me add it here. And now if I run this, now you can see that we have fixed this part up here. And I guess this part down here as well. So now we can do the same thing for the bottom right. And the bottom right is going to be a plus here. So this is going to be the bottom right. Then we can do the same thing for the bottom left. And this is just going to be negative for the x, and finally we get the top left. And for this, we just need a negative offset for the y. Now, if I run all of this, we have a much nicer looking outline. And I guess this one is a little bit thick, so let's change the 10 to a 4. Let's see how that looks. Yeah, that is significantly better. So this is a much nicer looking outline that you will probably want to rather use in the game. Or well, depending on the complexity of your surface, I guess. And I guess you could simplify this with a smart for loop, but in my case, I'm not going to worry about it. But it's something to keep in mind if you have an actual game. But with that, we have outlines and we have the ability to fill in a shape. So that's another project done. So we're almost finished. There's one more project to go. And this one is the most interesting one. Because for this one, we're going to color in only the parts of a surface that are overlapping with another surface, which is a really interesting effect for basically any kind of game and is a really good way to understand how a mask is going to work. So let's talk about how this project is going to work. And in the most basic sense, it's essentially a combination of project 2 and project 3. So from project 2, we are going to get the overlap method, except now we are going to use overlap mask. And this one is going to give us the overlapping mask between, well, one mask and another. And then from project number 3, we are going to turn this new mask into a surface and color every pixel in. And that's literally all we are going to need. It honestly isn't that much of a complicated project. So let's jump straight into the code and let's have a look at this. Here I am back in the code and I already have a couple of things set up. Let's talk through them really quick. It shouldn't take too long. Now, as always here, we have the usual setup. Now, besides that, we have the ship setup and the alpha setup. And for the ship, we have a surface, a rectangle, and a mask. And be aware, I already imported the mask. This is the step we haven't done earlier. Now for the obstacle, we have a surface, a position, and a mask. And this is pretty much the same thing we had before. So all of this should be fairly simple. Now then, here we have the usual event loop, and we are adding a background. Now a bit further down, really all we're doing here is we are drawing the background, then we're getting the mouse position and placing our ship, and then we're updating everything. So all of this should be pretty easy at this point. With that, we can get started to get all the stuff ready to actually get the mask first. And let me add a new comment here, and let's call this the new mask surface coloring. I guess that makes sense. I'm kind of bad at naming stuff. But anyway. Now the first thing that we do have to check is if there's a connection between our ship and the obstacle. And this happens again with an if statement. So if ship mask dot overlap with our obstacle mask, then we want to do stuff. So let's call it do stuff. Now there's one thing I did forget here, and I hope you remember, because what we need in here is in a tuple an x and a y, and both of these should be an offset. So we again have to get an offset, one for x and one for y. And let's see if you can remember what we have done in the second project. So pause the video now and try to find these two offsets. Let's try together now. And I guess let me write on both at the same time. That should save a bit time. Now, first of all, we need the obstacle position. And in here, we need x or y. I'm going to add those in a second. And from those, we are going to subtract the ship, rect, and then for the x position, it's going to be left and 0. So this is going to be x. And for the y position, it's obstacle position 1. And shipwrecked.top. So check out the earlier part to understand the logic here. At this point, it shouldn't be too difficult, or at least I hope it won't be. So now we can tell if there's a collision. And let's just check if this is actually working, just to make sure I didn't make a mistake, like I did with the typing. So now let's try this, and we are getting a collision. Cool. So this is already working. Nice start. So now we know when there is a collision from this line here. Whenever this happens, we want to create a new mask from the overlap between our ship and the obstacle. And this I also want to store in a new variable. And let's call it new mask. And to get this one, we again need our ship mask and then overlap. But this time, we are going to add mask. And this is going to return the overlapping mask between these two objects here. And it is going to need some arguments, although the arguments are exactly the same that we have used before. So I can just copy paste them and we are good to go. So I guess what we can do now, let's just print new mask and let's see what we get. And now if I touch the alpha, we get a mask that has this dimension. And well, we don't really have to worry about the specific details here, but we know we are getting a mask. So that's a pretty good sign. And now we have to pick up the stuff we learned from the third project. So we are going to turn this mask into a surface. And then on this new surface, we are going to go for every single pixel and color this pixel in a certain color. So what we need first is, let's call it new surface. And this is going to be new mask dot to underscore surface. And this does not need any arguments. And all right, now we have a surface. And I guess what we can do now is to actually blit this new surface. And this should happen inside of this if statement. Let me actually demonstrate. So what I want to do now is screen.blit, and I want to get my new surface. But now I am also going to need a position. And ideally, this should be a rectangle. And fortunately, I do, because this ship rectangle here, we can totally use in here. Because the new mask we are creating is going to be essentially the same size as this ship. So let's actually try how this is going to look. So we are just going to use the ship rectangle. So now let's try how this is going to work. And now if I touch the alpha, the ship turns black. But if my ship goes over the alpha, we can see the silhouette of the ship. So this is working really well. And now what we can also do for this new surface, we can set a color key. So I want to get my new surface. And then I want to set my color key. And the color I want to get rid of is 0, 0, and 0. So the color black. And let's add a bit of space here. And now let's try this again. And now, when my ship touches the alpha, we can see that we are just getting a white color. So this is already working really, really well. So that's a pretty good sign. So now all we really have to figure out is how to change this white color to essentially any color that we want to have. And this is what we learned in the third project. So let me give a bit more white space. And before I start, I would really recommend you to try this yourself. Because if you look at the past code, implementing this really shouldn't be all that difficult. And it would be really good practice, I think. So try this yourself and see how far you get. First of all, we need a surface width and a surface height. And this we get from our new surface and then get underscore size. And this is going to return a tuple that we need for the width and the height. Now, next up, I want to go for every single pixel in the width and the height. So for X in range surface width, and inside of there for Y in range surface H. And now inside of here, I want to check if my new surface.get at. So I want to check one specific pixel inside of this new surface. And this should be at a position X and Y. And if this is white, it's going to be 255, 255, and 255 as a tuple. So I can literally pick any number from this and check if this is different from 0. If it is, we know there's a pixel. If it isn't, we know it's going to be invisible or, well, black. So now, once we have that, all we have to do is get our new surface, and then set_add, get our X and Y again. And now all we have to do is to pick one specific color. Let's say in my case, let's go with red. And now let's try all of this. And you can already see it. Now this is working pretty well. So with that, we have a ship that shows an outline that we can only see if it overlaps with the alpha. So really wasn't all that difficult to implement, I think. So this is actually working really, really well. Cool. So I hope that was helpful, and I will see you around.